let's take some time to go over the applications of quadratics exercise solutions. These are just applications of finding the vertex and solving quadratic equations, and we're going to apply them to real-world situations with an emphasis on business applications. So a couple things that we need to recall from previous knowledge. You break even when your revenue is equal to your cost, and also when your profit is equal to zero. That your market equilibrium occurs when your supply is equal to demand. Just remember, when you're trying to set two equations equal to each other, they have to be in the same form, like P equals and P equals, or Q squared equals and Q squared equals. So they have to be in the same form before you can set them equal to each other. And also that your optimal value will occur at the vertex. So if you're looking for the maximum, that's going to be the top of your frowny face parabola. If you're looking for your minimum, that's going to be the bottom of your smiley face parabola. All right, so let's get started. Suppose the supply for a product is given by P equals Q squared plus Q plus 2, and the supply for that same product is given by P equals Q squared minus 3 plus 14. Find the point of market equilibrium. Remember, market equilibrium is when your supply equals your demand, so we can take this supply equation and set it equal to this demand equation, only because these are both P equals and P equals. Since these are in the same form, we can set that Q squared plus Q plus 2 equal to that Q squared minus 3Q plus 14. Now, the first thing I want to do is subtract Q squared from both sides, but what are you going to notice? The Q squareds are going to cancel. So then all I have to do is add 3Q over here and subtract 2 over there to get 4Q equals 12. Divide both sides by 4 to get Q equals 3, and Q represents the quantity. Now we're looking for the point of market equilibrium, which means we need to know how many and at what price. So we'll take this quantity and we'll plug it back into the supply equation, 3 squared plus 3 plus 2 equals 14. Or we could plug it back into this demand equation, 3 squared minus 3 times 3 plus 14. Notice they both give you 14. That's because this is the part where the point where they're equal, so they should give you the same y value. So it doesn't actually matter if you plug back into the supply or the demand. You don't have to do both. So we will need to sell 3 units at $14 each to reach our market equilibrium. Let's look at another one. So we have a supply equation and a demand equation. Now notice, this is not like that previous one where we had P equals and P equals, but here we can easily solve for P by just adding P to the other side. Here we can solve for P by subtracting Q squared and subtracting 4Q, so we can get that Q squared plus 8Q plus 20 equals P for our supply, and that P equals 100 minus Q squared minus 4Q for our demand. Now that we have P equals and P equals, we can set them equal to each other. And now this is a quadratic where we'll get everything on one side, 0 on the other. So I will add this Q squared, I will add this 4Q, and I will subtract this 100 to get 2Q squared plus 12Q minus 80 equals 100. So now I'm trying to solve a quadratic. We'll do that by factoring. And this factor out of 2, they both have a 2 in common, and I get Q squared plus 6Q minus 40. This here will factor into your Q minus 4 times your Q plus 10. And so now we're going to set our factors equal to 0, but only the ones that have a variable, like this Q minus 4 and this Q plus 10. And when I do that, I get Q equals 4 and Q equals negative 10. But remember, Q represents quantity. It's the number of units. It's how many units of whatever your product is. It doesn't make sense to have negative 10 units. So you can't sell a negative amount of units. So we'll have to go with this positive one, Q equals 4. So now we know our quantity. We'll just plug it back into either supply or demand. It doesn't matter which one to get our price. Because remember, this is where supply is equal to demand, so the price should be the same. So 4 squared plus 8 times 4 plus 20 gives me 68. If you plugged it into the demand equation, you would have gotten the same thing. So we need to sell 4 units at $68 each in order to reach our market equilibrium. Suppose the cost per week to produce X Blu-ray players is given by 3,600 plus 100X plus 2X squared. And that we also know that the weekly demand is P equals 500 minus 2X. Let's start by finding how many Blu-ray players we need to produce in order to break even. Well, when do we break even? We break even when revenue equals cost, but I've got cost, I don't have revenue, I only have our demand equation, which gives price. Or we can set profit equal to 0, but again, I only have my cost and I have my demand, which gives me price. So what do? Well, think back. What is revenue? Revenue is price times quantity. The demand equation gives us price, and the quantity is right here, x. So I can find my revenue function by taking P times x, or that 500 minus 2x times your quantity x, distribute the x, and we get 500x minus 2x squared. So now I have my cost equation. I found my revenue equation. Now I can find my break-even point by setting my cost equal to my revenue. Get everything on one side of the equal sign, so I'll subtract the 500x, and I'll add the 2x squared to get 4x squared. I will, of course, put it in descending order, highest power down to smallest power. For me, it makes it easier to factor. I'll pull out a 4, and then that factors into x minus 10 and x minus 90. Set the factors equal to 0, and I'm going to get x equals 10 and x equals 90. What does this mean? This means we're going to break even twice. Well, if you think about it, when you start selling a product, your sales go up, you eventually break even. They continue to go up, but eventually pretty much everybody who wants one has one, so your sales start to come down. You break even again, and then you might start to lose money. So it does make sense in the business world to break even twice. We break even twice at the sale of 10 Blu-ray players and again at 90. Let's continue this same example a little bit more. How many Blu-ray players do we need to maximize the revenue? What is the maximum revenue? And how much does it cost to make that many Blu-ray players? So we're looking for maximum revenue. Remember what our revenue function was, 500x minus 2x squared. This is a parabola. Notice A is negative, so it's a frowny face parabola, which means the maximum revenue is going to happen right up here at the vertex. So let's find the vertex. The x will be negative b over 2a, which is going to give me 125. That represents the number of units. So how many Blu-ray players do we have to sell to maximize the revenue? 125. What is the maximum revenue? Well, we can take this quantity, plug it into the revenue, and that will tell us how much money we will make from selling 125 Blu-ray players. So that's $31,250. Now, how much does it cost to make that many Blu-ray players? Let's go back to our cost equation and plug in 125, and we get $47,350. So it's going to cost us $47,000 to make the 125 Blu-rays players, but our maximum revenue is only going to be $31,000. So the idea behind this, to use these functions, is kind of a predictor. And we can see this isn't good. You don't want to spend more than you're going to make selling your product, so something needs to change. Maybe you need to find a way to produce them at a cheaper value, or maybe you need to charge more for your price and make them more expensive so you make more money in revenue. And that's what you're going to have to talk about with your company. So given the profit function to produce and sell x units of a product is 11.5x minus 0.1x squared minus 150, let's find the break-even point. Remember, another way we break even is when our profit is equal to 0, so we'll set the profit function equal to 0. My next step would be to factor. I don't want to use the quadratic formula because that takes too long. Well, what I have here is a perfectly balanced equation. The issue is I've got decimals. That doesn't make the factoring that nice. However, because I have a perfectly balanced equation, I've got a left-hand side equal to a perfectly balanced right-hand side, you can do whatever you want to an equation as long as you do it to both sides. Ideally, this number right here would be a 1, a positive 1. So what I can do is just multiply both sides by negative 10. Distribute that negative 10 to everybody here and over here, and I end up with x squared minus 115x plus 1500 equals 0. That is much easier to factor, and when I factor that, I get x minus 15 times x minus 100. Set those factors equal to 0, and here we go. We break even twice again, at the sale of 15 units and again at the sale of 100 units. Suppose the cost to produce x units of a product is given by x squared minus 400x plus 100,000. How many units will minimize the cost? And what is the minimum cost? Look here, we have a parabola. The a value is positive, so it's going to be a smiley face parabola. The minimum is going to be right here at the bottom of the vertex, or the bottom of the U, which is the vertex. So when you're looking for the minimum, you're looking for the vertex. So x equals negative b over 2a is going to give us 200. X is the number of units, so that tells us we need to make 200 units to get the minimum cost. What is the minimum cost? We'll plug 200 into the cost equation to get 60,000. So we need to produce 200 units to minimize the cost, and the minimum cost will be $60,000. Suppose the cost to produce X units of a product is given by 1,600 plus 1,500X, and that the demand for that same product is 1,600 minus X. Find the maximum profit. I have cost and price, and I want profit. Well, how does one find profit? Profit is revenue minus cost. I don't have revenue. But recall, how do you find revenue? Revenue is price times quantity. So I can take this price times this quantity, distribute the X to get a revenue function of 1,600X minus X squared. So now I have a revenue function and a cost function. I can find my profit by doing revenue minus cost. Remember, I'm subtracting the entire cost function, so I need to subtract the 1,600 and the 1,500X. Combine my like terms, and I get that my profit function is negative X squared plus 100X minus 1,600. So where am I going to find this maximum profit? Well, take a look. This is a parabola with a negative leading coefficient, so it's a downward facing parabola. The maximum is going to be right up here at the top, which is the vertex. So I'm looking for the vertex of that profit function. The number of units will be negative b over 2a, which gives me 50. But that's not what the question asked for. It said, what is the maximum profit? So I know how many I need, 50. I'll plug that back into my profit function to get 900, and we will see that our maximum profit will be $900. That's it for now. See you next time.